press the first, draw this region. And if you're not sure what a graph looks like immediately, try making a quick x and y data table. Plug in a number for x, see what it spits out for y. So let's try 2, that gives us 0, because 2 squared is 4. Let's try -2, that also gives us 0. And we know it's quadratic, so it should make some sort of parabola, like this. I made it like this instead of like this because there's a negative sign in front of the x squared variable. So 0, 4, there's a dot. 2, 0, there's a dot. 2, 0, there's a dot. So the first graph looks something like this. And this is y equals mx plus b. Starting dot at 2 goes down 1 to the right 1, down 1 to the right 1. Yeah, so this is going to cross right here. So there is the region between these two curves. And you want to find out for sure exactly where they cross so we can answer the next question. And you can do that by setting them equal to each other. 2 minus x equals 4 minus x squared. Then if we solve that like a quadratic, I'm going to set it equal to 0. So subtract 2 from both sides and add x to both sides. We've got -x squared plus x plus 2, because I subtracted 2 from both sides, added x to both sides. I'm going to multiply both sides by -1. That way my leading term is positive. And so this is factorable. Two numbers that multiply by -2 but add up to be -1, like we've done in previous math classes. Okay, so it crosses at x equals 2 and at x equals -1. So when we find the volume of this region rotated around the x-axis, we want to integrate from -1 to +2. And since we're using the washer method, what we're going to do is we're going to construct the equation of two different circles. And then that's a two-dimensional thing. When we integrate it, that brings it into the third dimension, and then we're talking about volume. The first circle I want to construct is the circle with a radius that goes all the way from the x-axis, our axis of rotation, all the way up to the bigger part, the y equals 4 minus x squared. Okay. And then I'll construct the equation of a circle that's always the smaller part, and we'll just subtract those two volumes. Okay, so this circle, if it's revolved around the x-axis, this would be a slice. If you take that slice out of the volume that we're trying to, the figure that we're trying to create, that circle would have a radius just from the x-axis to this line. So this y value represents the radius of all those blue circles that we're cutting out. So to find the area of a circle, this is going to be pi r, this is our radius, because that's what y is equal to, pi r squared. And then we said that was the smaller one, so that's why I put it to the right over here, because we're going to subtract that by the bigger area, the bigger circles, when they're revolved. So same thing with this, the radius is the y value, the distance from the x-axis to here, to the y value. And this is how we calculate the y value with respect to x. So it's pi r squared, and then this is all with respect to x. And that's it. So if you integrate this, you should be done. So the algebra might get a little bit tricky because we're squaring parentheses, so I'll start you off with that. Factor out that pi too while we're at it. Get that out of here. This is -1 to 2. And then if I'm going to square this parentheses, that means I'm doing 4 minus x squared times 4 minus x squared. So that gives me 16. And I'm going to have minus 4x squared, then minus 4x squared, so that's minus 8x squared. And then we've got -x squared times -x squared, that makes positive x to the 4th. And then over here, if I square this parentheses, it's, oh yeah, I'm subtracting everything from this parentheses, so watch out for that. After I square that parentheses, I'm going to get 4, so that's minus 2x minus 2x, that's minus 4x total, and then plus x squared. This is all dx. So we can combine like terms. 16 minus 4 is going to give me 12. Negative 8x squared, that's going to be minus x squared, so that's minus 9x squared. This x to the 4th has nothing to combine with. And we still get this minus a negative 4x, so plus 4x. And the integral operator is a linear operator. It means we get to go term by term when we find the antiderivative. So the antiderivative here is 12x. Antiderivative of the next one, that's 9x to the third over 3. So that's going to be 3x to the third. This is going to be x to the fifth over 5. And then this is going to be 4. It's 4 over 2. So that's just 2x squared. And then limits of integration, negative 1 to 2. So if I plug in 2, I'm going to get 24, and 2 to the third is 8. 8 times 3 is 24. So 24 minus 24 is going to give us 0 when I plug in 2. And then I've got 2 squared is 4. 4 times 2 is 8. So I've got 8 plus, what's 2 to the fifth? 8 plus 32 over 5 when I plug in x equals 2 into our antiderivative. Now if I plug in negative 1, that's going to give me negative 12 minus a negative 3. So that's negative 9 now. Negative 9 plus 2 is going to give us negative 7. So we need to subtract negative 7. And this is going to be subtract 1/5 because when I plug in negative 1 up here. So that's 15 minus a negative 1, so that's plus 33 over 5. So 15 times 5 plus that 33, so I'm going to get 108 over 5 pi.